Welcome to the Journey Shape Chem. Well, today you have some more dot diagrams to draw and a short question. So it really balances out. You have one that takes a while and one that should be short. So do the best you can, and we'll see you in a moment. In 1A, we have a compound where carbon is the central atom. And then carbon has 4 valence electrons. Now, very easily, the hydrogens that have 1 outer electron will bond. And then I'm going to move this electron to the side, and I need 2 more electrons. Therefore, I'm going to double bond the oxygen. And in this way, I have carbon and a double bonded oxygen. I have 3 bond pairs and no lone pairs. Therefore, this shape is trigonal planar. And it has a 120 degrees. And that's what we needed to do. We have to circle the octets. And the duets, of course. And then we have to give the shape, the line structure, and the angle. The shape, the line structure, and the angle. And that is 1A. In 1B, silicon is the central atom. And silicon also has 4 dots. And I'm going to double bond my oxygens on both sides in order to get my octet. And therefore I have 8 electrons around the silicon and 8 around each one of the oxygens. And the line diagram, remember there is 1 line for each pair of electrons. Here we have 2 bond pairs and no lone pairs. Therefore this shape is linear. And it is 180 degrees. And that's how you do A and B. Number 1C, carbon is my central atom. Carbon has 4 dots. And each hydrogen has 1. And that works out pretty nicely in that chlorine has 7. And this one makes it 8. And therefore we get our octet. Carbon has an octet, chlorine has an octet, and hydrogens have their duets. And when I draw this, I see carbon is in the middle with chlorine, hydrogen, hydrogen, and hydrogen. And you'll recall that these are not opposite of each other. It is a tetrahedral shape. You might want to review that and look at those balloons again. Now, nitrogen, we need to know the angle. Because it is a tetrahedral, because it has 4 bond pairs and no lone pairs makes it a tetrahedral. And the angle is 109.5 degrees. Now for nitrogen, we have 2 nitrogens, and any time that we have 2 atoms, just like 2 points make a line, 2 atoms will make a linear shape. So nitrogen has 5 outer electrons, 5 valence electrons. 1, 2, 3, 4, 5, and this nitrogen has 5 as well. And therefore I get 8 around both nitrogens by triple bonding. And the triple bond is lots and lots of energy in there, and that's why nitrogen compounds are often used for explosives. And sometimes we write them, the structure, with the lone pairs on either side, and sometimes not, because it's not going to affect the shape of this molecule. It is a linear molecule. with 180 degrees. Now, number 2 is asking for why do electron pairs spread out as far as possible? Well, they do that to minimize the repulsive forces. They want to minimize the repulsive forces. That's very important because that is exactly what's going on between the bond pairs and the shared pairs. Electron clouds repel each other, but they have to stay together because they're sharing. It's like when you get angry with your parents and you just go to another room. You go to the farthest part in the house to get away, but you still have to stay home. So there's not a whole lot you can do. Just the same way, the atoms are repelled by those electron clouds, but they have to stay together because they're sharing those electrons. So they spread out as far as possible in order to minimize the repulsive forces. Now I'm going to be right back and we're going to take a few notes. We are going to discuss polarity. Polarity is when molecules have an unequal distribution of charge. One side of the molecule is more positive and one side is more negative. Now, the shapes of those that follow the octet rule, if they have a lone pair, they're going to be polar, because the lone pair is very negative. For example, when we have water, and we drew this before, and we see that it has 2 lone pairs, it's very negative on this part. And sometimes we show it as a sigma, a lowercase sigma, and this side is more positive. Sometimes they show you that the electrons pull towards the oxygen. That's another way of showing it. They pull in this direction. This molecule would be polar. It has an unequal distribution of charge. It has one side that is slightly negative and one side that is more positive. That makes it polar. Now, in general, what we do when we're looking for polarity, there are 2 things that we can look for. The first one is symmetry. If the molecule is perfectly symmetrical, then the pull for the electrons is identical all the way around, and that would make it nonpolar. We have to look specifically at the molecule. The second thing we look at is electronegativity differences. And you will see this when you do the lab. If the difference between the 2 atoms is greater than 1.67, it is considered to be primarily or largely ionic. And if the number is less than 1.67, it's considered to be primarily covalent. And if you have the same 2 elements like oxygen and you subtract their electronegativity differences, then it would be 0 and they're completely covalent. Also, we look at the molecules and we know that when we have nonmetals and nonmetals, we're going to have covalent bonds. But when we have a metal with a nonmetal, it's going to be ionic. No matter what the difference is, it will be ionic. You have to look at the atoms that are being discussed. But this is a guideline to show us in what direction it goes. So those are the 2 things that we look at to determine polarity. And the important thing to remember, if a molecule is polar, it has one side that's more positive and one side that's more negative. And it's very important for why water is used as the universal solvent. When we put salts in water, they separate into their ions. And the positive sodium ions will be attracted to the negative part of the water, and the negative chloride ions will be attracted to the positive, and water will actually rotate so that this positive portion will surround those negative ions and the negative portion will surround those positive ions. And that's how it occurs in water. Well, those are the 2 characteristics. And I know that you'll practice this and you'll get a lot of practice on the lab that's coming up. Well, I can't wait to see you tomorrow, and we'll see you then. Bye-bye.